In this problem we want to find the current I and the voltage V using node voltage analysis. This is a problem that illustrates that no matter where you try to choose the reference voltage, there's always a floating source. For example, if I choose the reference here to ground this end of the source, then this one is floating. If I choose ground as the usual spot on the bottom, then the top one is floating. So no matter where you choose it, you always have to have at least one floating source. So I'm going to go ahead and leave it attached on the bottom, and two node voltages we have to find are V1 and V2. This voltage is already 14. So let's go ahead and do this at node 1. The current going off to the west, V1 minus 14 over 4, our southbound current. And again, at this point you ignore the stated current I and just go with it in terms of what you need to do to write your node voltage equation. And current heading off to the east is the same as what's going through the source here, the same as the source through there, which in turn is the sum of the current that's heading to the south plus the current that's heading off to the east. So that equation then essentially takes care of it. At node 2, we do not need to write a KCL equation, but rather observe that the potential at V2 is basically V1 plus the voltage rise associated with that 4-volt source. These two equations can be solved to yield V1 equals 2 volts and V2 equals 6 volts. So the desired circuit quantities could be found like this. In this case, I is V1 over 2. So that means we've got one amp is a result for I. V, it turns out, is just the same thing as V2, so that means V is